Problems 19, 20, and 21 from the Chapter 3B quiz review. We're still looking to solve, just like we were on the previous page there. So what we're going to do here is, let's just look at this equation. We've got log of the quantity x plus 1 plus log of the quantity 2x plus 1 is equal to log base 4 of 4. So it appears that we've got 3 logs in this, okay? Our logs on the left side are both base 10, and the log on the right side is base 4. But this expression here, right, log base 4 of 4, we know really equals 1. So let's just go ahead and change that to 1. And anytime we have more than one log on the same side of an equation, our goal has to be to rewrite it as one log. So we're going to use our log properties here to rewrite this as log of the quantity x plus 1 times the quantity of 2x plus 1. In which case we could take that and actually, FOIL it out already if you wanted to. But now that we have just one log, remember our implied base is 10. So if we think about it here, let's just rewrite it. Since we have one log on one side, let's just rewrite it to its exponential form. So what I now have here is 10 to the first power is going to equal the quantity of x plus 1 times the quantity of 2x plus 1. Well, to solve this, right, we don't have a product property that equals 10. It has to equal 0. So what we're going to need to do here is simplify the right side by foiling it out. We should have a 2x squared plus 3x plus 1 equals 10. And now we can subtract 10 from each side here, and we're going to get 0 is equal to 2x squared plus 3x minus 9. And we'll take that here, and that should factor. When it factors here, we should get a 2x in the front, an x in the front. We'll have different signs there, so it looks like we're going to have factors of 9, or either 9 and 1 and 3 and 3. Looks like in this case here, we're going to want to go 3 and 3. And I believe, let's see, so we would need to have more positives than negatives. So we want to put a minus 3 on the left and a positive 3 on the right. Now this still equals 0, so we're going to do our 0 product property to solve it. So this one should be x is equal to 3 over 2. And this one should be x is equal to negative 3. And then remember, we need to take these values and plug them in to make sure that it doesn't give us a negative value in our logs here. So when I do that 3 halves plus 1, or I do 2 times 3 halves plus 1 in there, we get positive values there, right? So for this one here, this one's going to work. We'll keep that. When we plug in negative 3, though, we get negative 3 plus 1 inside those parentheses, which is a negative 2. That's not going to work for us. So we can go ahead and toss that one out. We don't even have to do the second one. If it doesn't work in one, it doesn't matter. So now we've got x is equal to 3 halves or 1 1/2, however you want to write it down. All right, let's look at number 20. For this one, we've got a log equation, log base quantity of x minus 1 of x plus 5 equals 2. Well, let's take it here since it's in log form. Let's go ahead and use our giant spiral to get it to its exponential form. So we've got the quantity of x minus 1 squared is equal to x plus 5. Okay, to solve this, we're just going to have to simplify. We're going to have x squared minus 2x plus 1 equals x plus 5. Let's set it equal to 0. So we're going to subtract x and subtract 5. So x squared minus 3x minus 4 is equal to 0. That looks like it's going to factor for us. We're going to have an x minus 4 and an x plus 1, which then leads us to solving it and getting x equals 4 and x equals negative 1. Well, remember, we got to take them and plug them in. If we plug in -1 into our base, we'd have log base -1 minus 1, which would be log base -2, and we can't have that. So we have to throw out our -1. If we throw 4 into each of them, it should work because we'd have, 2 is equal to log 4 minus 1 would be 3 of 9, which does make a true statement there. So x equals 4. And then when we look at number 21 here, we have log base 4 of log base 3 of 5x equals 1/2. So I'm going to go ahead here and just rewrite this one as in its exponential form. So we've got 4 to the 1/2 power is equal to log base 3 of 5x. 4 to the 1/2 power is just the square root of 4, so we're going to say 2 equals log base 3 of 5x. And since we have another log expression here, let's just go ahead here and rewrite its form again. Let's do 3 to the 2nd power should equal 5x, which really is 9 equals 5x. And we'll divide each side by 5. So we get x is equal to 9/5. Now for time's sake here, I'm just going to tell you that if we plug in 9/5 back in here for x, it does work. So we should be good with that. So for 21, x is equal to 9/5.